So we're going to have to quickly review the rational zeros theorem. That might not make any sense to you, but the P and Q, does that make any sense? That's the rational zeros theorem. Maybe you should write a P and a Q by that to help you associate. The rational zeros theorem is just a P and Q. That theorem only helps you find rational zeros, but the topic for today is finding all zeros. So we're going to find all of them: rational, irrational, imaginary. We're finding all the zeros. Just to hit this one more time, not to beat a dead horse, but I want to show you something, and then I want to contrast it to what we're doing today, because it's very similar, very, very similar. This was your quiz question. X to the third plus, I think it was 5x squared minus 4x minus 20. Isn't this one you had in the quiz? And it was equal to 0, right? And, well, I'm going to make it equal f of x. It's pretty much the same thing. Tell me what you guys did. Almost all of you raised your hands saying that you successfully solved this one, so help me out. We factored by grouping, right? We had x squared factored out. That left x plus 5, and then from here you factored out a negative 4. That left x plus 5. So then you factored out an x plus 5 from that, and that left you with x squared minus 4. So then the zeros were x equals negative 5 and x equals plus or minus 2. And then I didn't ask you to do this on the quiz, but I am going to ask you on today's assignment to write the polynomial in fully factored form. This was partially factored because you only had 2 factors, but there should have been 3. So now that you have all 3 zeros, it would be x plus 5, x minus 2, and x plus 2. That's fully factored. Why is that fully factored? Because we have all 3 factors. Okay? So let me just explain what you're going to be doing today. You're going to be finding all the zeros and then writing it in fully factored form. That's it. Okay? But let me show you what the difference is. This one wasn't so bad, right? Here's what your first example is going to be. I don't want you to write it down yet because there's a few things we have to do first. But let's just consider... not that one. This one here. F of x. Ooh, hold on. Let me write it down. So it's the same set of directions. I need you guys to look up here. X to the third minus x squared plus x plus 39. I want you to find all the zeros and then write it in factored form. What's the problem here? If we try to do the exact same thing that we just did on the problem from like 5 seconds ago, wouldn't we try to factor by grouping? And then from the first factor, you could still take out an x squared. That leaves you with x minus 1. But what could you take out of the second group? You could take out a plus 1, really, but that still leaves you with x plus 39. Do you see the problem? It does not factor by grouping. So that's where this rational zeros things comes in. These problems are not going to factor by grouping like on the quiz. There's got to be a different way. So that's why... Whoop, what am I doing here? Here we go. That's why I'm having us review that P and Q nonsense. So let's go back. Let's review the rational zeros theorem. Here's example 1. Example 1, rational zeros theorem. Find all of the possible rational zeros. And let's use this as our example problem. F of x is x to the third minus 4x squared plus 9x minus 36. It's just that P and the Q stuff. We did this a couple of days ago. Now, what are the factors of P? Where are we getting the numbers from, Gavin? Yep. Yep. The constant at the end, that's where we get P from. So plus minus 1. Oh man, 36 has a ton of them. Plus minus 1. Plus minus 2. Plus minus 3. Plus or minus 4. Plus or minus 6. Now we start to loop around. 4 times what is 36? So there's the 9. 3 times what is 36? 12. And 2 times what? And finally 1 times 36. Those are all the factors of P. Q is just the number in front of x to the third plus or minus 1. That's kind of nice when Q is plus or minus 1, because really what we're interested in is P divided by Q, not just P and Q separate. It's P divided by Q. But if Q is 1, then P divided by Q is this list right up here. It's just your factors of P. You guys are over there? If Q is just 1, then P divided by Q are just those factors of P right there. Those are all of the possible rational zeros. Now I want you to find ones that actually work. Those are the possibilities. Which ones actually work? How did we figure it out? Graphing. Yep. We figured it out by graphing, because rational zeros are the same as x-intercepts. So if there is a number from this list that works, we can find it from the graph. So go to the graph. I shouldn't have to show you this. You guys do it. And then tell me which ones work. Go ahead and give it a try. Graph it on your calculator, find x-intercepts, and then actually verify that they work by hitting trace and making sure. Did we find any? And did you verify it on the graph? Did you type in -4, hit enter? Was it really 4? That's positive for me? Okay. What's that? Yep, now you do synthetic division. We know that x equals 4 is a 0. We verified that graphically, but I still would like you to verify that numerically with synthetic division. So go ahead and do the synthetic division. We know x equals 4 is a 0 because we saw the dang graph. That was easy enough to do. So now do synthetic division and verify it. Did it work? Yeah. Really? So you drop down the 1. 4 times 1 is 4. 4 plus -4 is 0. 4 times 0 is 0. 9 plus 0 is 9. 4 times 9 is 36. Hey, look at that. It did work.
Where's the notebook? Are we turned in for
there? I haven't got through all of them yet. Do you need it real bad?
Yeah, I need pretty much.
Sure. Take it. Isn't that what we did on the last worksheet, right? Now, I want to review one more quick thing before we actually get into... This is going to be a little more of listening skills and trying to understand what I'm saying. Okay? So I really need you to listen. Okay? If I take the number, I don't know, 12, and I want to figure out what the factors are of 12, if I divided it by 5, for example, am I going to get a remainder of 0? So that means 5 is not a factor, right? You know that, right? If I took it and divided it by 4, wouldn't I get a remainder of 0? So doesn't that prove that 4 is a factor? Now, I know you guys know this, but it also does one other thing. It provides us with one more factor. What is 12 divided by 4? So not only did we prove that that's a factor, didn't it give us that other factor as well? You guys following? So isn't it now true that since we know this is a factor and that's a factor, I could rewrite this problem. Instead of 12 divided by 4 equals 3, couldn't I write that as 12 equals 3 times 4? Are those the same thing? Now I want to try to extend this beyond numbers to some expressions. If I took x squared minus x minus 12 and divided it by x minus 4, how do I know that x minus 4 is really a factor of x squared minus x minus 12? How do we know that 4 is a factor of 12? We got a remainder of 0. So how do I know if x minus 4 is a factor of that? You could do long division. We could, but couldn't we do synthetic division as well? Let's just quickly go through this. If we did the synthetic division, 1, negative 12, and then we synthetically divide it by positive 4, if this really is a factor, what should we expect to get? Let's see. Do we? Drop down the 1. 4 times 1 is 4. 4 plus negative 1 is 3. 4 times 3 is 12. We get a remainder of 0. Now, I want you to really try to understand what just happened here. We've done two things, just like the same two things we did here. Did I prove that this was a factor? Yes, because I got a remainder of 0. But didn't this also give me another factor? We know that x minus 4 is a factor, but what's the other factor? What does that 1 and that 3 really represent? 1 and 3? Well, this is what we divided it by. But wouldn't this be the result of the division? If x squared minus x minus 12 is divided by x minus 4, what's the answer? The answer is not just remainder of 0. What's the answer? It's x plus 3. Okay. Now, I'm starting to lose some of you guys. You really need to stay focused here. Your minds are wandering. Did we prove that x minus 4 is a factor? Did we also then prove that x plus 3 is a factor? How did we know that? Because we got a remainder of 0. So now I could write this, x squared minus x minus 12, kind of like what we're doing here, is x minus 4 times what? X plus 3. Now, I want to go back. Did we prove that that number right there, 4, did we prove that it was a 0 of the polynomial? Yes or no? Doesn't that also mean that x minus 4 is a factor then? If x equals 4 is a 0, then x minus 4 is a factor. Do you see the relationship? Well, because the remainder is 0, not only is this a factor, but doesn't this give us another factor as well? That would be x squared plus 9. Okay? It's really important to understand what the remainder of 0 means. It doesn't just mean that this is a 0. It also gives us another factor of the polynomial. That's why synthetic division is so important. Okay? X squared plus 9. If you start from the furthest to the right, that's just a number with no variables. That's why it's plus 9. Right? The next number over would be the x number. Since it's 0, there is no x number. The next number over is the x squared term. Following. So this was an x squared. There is no 0 term, or there's no x term because it was 0. Does that make sense? Okay. There was a whole reason for that. Let's get back to that problem I showed you earlier. This one cannot factor by grouping. How can we find zeros if it can't factor? Well, it doesn't factor using normal factoring techniques. It does factor, just not the way that we're used to. It doesn't factor by grouping. We can find the factors using synthetic division, just like this. By getting a remainder of 0, we got that factor and we got this factor. You guys follow? It's the same thing that we're going to do here. So, if you cannot factor by grouping, these are the steps that you take. You use the rational zeros theorem to find all the rational zeros. So let's try that. That's the P and the Q stuff, if you're still wondering what the rational zeros theorem is. It's the P's and the Q's. So, what are the factors of P? Plus minus 1. Ooh, 39. This is kind of a weird number. 3 goes into it. Plus or minus 13 and plus or minus 39. So there aren't very many of them. Q, luckily for us, is just plus or minus 1. So the P divided by Q list is just this list right here. Since Q is equal to 1, then P over Q is just P. Those are the possible rational zeros. Which ones actually are rational zeros? How do we know? Graph them. X to the third minus x squared plus x plus 39. Hopefully we can find a few rational zeros on here. Ooh, look at that. Kind of looks like negative 3, right? Sounds like negative 3. It smells like negative 3. Is it really negative 3? How do we know? Hit trace, type in negative 3. All right, it really does look like negative 3 works. But you still need to verify it using synthetic division. So do the whole synthetic division. Negative 3 times 1 is negative 3. Negative 1 plus negative 3 is negative 4. Negative 4 times negative 3 is 12. 12 plus 1 is 13. 13 times negative 3 is negative 39. And boom! Get a remainder of 0. This is the important part. Step 2. Use the synthetic division to write the polynomial as a product of factors. And it's exactly what I just tried to explain. Okay. This remainder of 0 is more significant than just proving that that's a 0. Okay. Taylor, do you want to shut the door for us? That is way too loud out there. Thank you. Let me try to explain this one more time. Because the remainder was 0, synthetic division has given us 2 factors. We know that x plus 3 is a factor because of right here. And then we also know that this is a factor because the remainder is 0. What is that factor? X squared minus 4x plus 13. So I'm going to rewrite the polynomial as this factor, x plus 3, times that factor, x squared minus 4x plus 13. So f of x equals x plus 3. We know that x plus 3 is a factor because negative 3 was a 0. We proved that. In addition, we've proved that this remaining polynomial, x squared minus 4x, we've proven that that's a factor. Question for you. Is that fully factored? Because the main purpose here is to fully factor f of x. Is that fully factored? Okay. We'll get to that in just a second. You're absolutely right. Is it fully factored? Yes or no? How do we know it's not fully factored? There's not 3 factors. How do we know there have to be 3? Well, it's a degree 3 polynomial. We have to have 3 factors. We got 2 of them, so we're close. Okay? This quadratic factor, x squared minus 4x plus 13, that's the problem. Okay? We've already found 1 0 from that factor, x equals negative 3. How many factors are going to come from, or how many zeros are going to come from this? Well, from the whole thing, we're going to get 3. We've already got 1 of them from here, so how many more to go? 2 more to go. 2 more from that one. Look at that one, though. How are we going to find the zeros from that one? Quadratic formula. Why does it have to be quadratic formula? It doesn't factor. Now, sometimes, you guys listen carefully, sometimes that will factor. Sometimes. Okay, but x squared minus 4x plus 13, this just happens to not factor. So we are going to have to use, that's what step 3 here says. Find the zeros from the quadratic factor. This is the quadratic factor. Find the zeros from the quadratic factor by either factoring, if it does factor, or the quadratic formula. I'm glad you're excited about it. If you practice it. These problems can be a bit lengthy. All right, then, let's just get to it. Should we sing the song? I feel like we should sing the song. Plus or minus the square root, right? You remember that one? Yeah. All right, the opposite of b is 4 plus or minus the square root of b squared, which is 16 minus 4 times a times c all over 2a. So that's 4 plus or minus, oh boy, 16 minus 4 times 1 times 13. What is 16 minus 52, I think is what that is. 16 minus 52? Negative 36. Well, that's not so bad. Negative 36 all over 2. What is the square root of negative 36? 6i, yeah? So now we have 4 plus or minus 6i all over 2. I'm going to separate this. Instead of one big giant looking nasty fraction, I'm going to separate this into 4 over 2 plus or minus 6i over 2. What is 4 over 2? 2 plus or minus 3i. And there you go. Those are the other 2 zeros. What was the first 0 that we found? So x equals negative 3 and x equals 2 plus or minus 3i. Those are the 3 zeros. That's all we have to find, right? There's only 3 of them? Because it was a degree 3? That's really as hard as your problems are going to be on the homework. They will be no more difficult than this one here. There is one additional thing, though. You remember how I said this was not fully factored right here? Now we can fully factor f of x because we know what all 3 zeros are. So x plus 3 from this 0 right there. The other 2 factors are going to come from these zeros. x minus 2 plus 3i, and x minus 2 minus 3i. Woo! That is what we're doing today, pretty much. Okay. Yep.
There were two parts to this question. Let's make sure we understand what's happening. Did we find all the zeros? Yes or no? What were they? X equals -3, x equals 2 plus or minus 3. The other part of your answer is going to be write it in factored form. Did we write it in factored form?
Yeah.
That's this right here. How do we know it's fully factored? Because there's 3 factors and it was a degree 3.
Okay. Truly, it does not get any more difficult than this problem right here. It's about as hard as it gets on your own. Okay. Here's problem. This is problem number 4. I need to run down to the copier and grab your homework. This is problem number 4 off your homework. Okay. So get a little bit of a start on it. I'll be back in just a few minutes with your homework. Get a little bit of a start on it. This is number 4. So I'm hearing what, -3 works? That was the only one? So okay. So did you do the synthetic division there like that? To prove it? Not only to prove that -3 worked, but also to find what the other factor was, x squared plus 8x plus 20. So hopefully you got to there. F of x equals x plus 3 times x squared plus 8x plus 20. And then you set up the quadratic formula. -8 plus or minus the square root of 64 minus 4 times 1 times 20. And then 64 minus 80 is -16. Square root of -16 is 4i, so you were to get to here, then -8 plus or minus 4i over 2. And then if you split this up, this is -8 over 2 plus or minus 4i over 2. And hopefully, if you were careful, you got down to there. -4 plus minus 2i, right? So then you write f of x in fully factored form. X plus 3 x plus 3, and then gotta be careful with these ones. X plus 4 minus 2i, and then x plus 4 plus 2i. Huh? Now, I haven't heard any bell ringing yet, so should be putting stuff away. Let's do question number 1 together. Just to save yourselves a little bit of time, you guys, you listening to this? Just go right to the dang graph. Look at the equation, go right to the graph, graph it, see which one's actually working. Okay? That's what I'm going to do on question 1. X to the third minus x squared minus 7x plus 15. What? Are you kidding me? -3 again. Getting sick of -3. Is it really -3? No, it's just A weird coincidence so far. It is really -3. All right. Well, let's synthetically divide now by -3. Not to prove that -3 works. We already know -3 works. We're actually trying to find what the other factor is. So, what is it? X. So we have a 1, a -1, a -7, and a 15. So drop down the 1, multiply, add, multiply, add, multiply. It does work. It's close. It really doesn't, though. I know it looks like it does. So right now we have this. F of x equals x plus 3 because we know that -3 works. The other factor is x squared minus 4x plus 5.
Now you look at that and think, oh, dang it, that should factor. It's close. But nothing multiplies to positive 5 that adds to -4. Dang it. They both have to be negative or they both have to be positive. So, yeah, no factor.
Now we get to do quadratic formula. The on or nay, the privilege. 4 plus or minus the square root of 16 minus 4 times 1 times 5. All over 2. This is 16 minus 20. Does anybody know what 16 minus 20 is? -4. So we have x equals 4 plus or minus the square root of -4 all over 2, which is 4 plus or minus 2i all over 2, which is 2 plus or minus I. So those are 2 of the zeros. We already knew that the other one was x equals -3. So those are all of the zeros. X equals -3. And x equals 2 plus or minus I. The bell's going to ring here, but you'd have to put those in the factors. But that's all you're doing. What's your assignment? Remind me. 1 through 10. Save 11 and 12 until you get back.